F-22 fighter jet pilots are terrified of this plane. We have all heard about the F-22 jet fighter because it's known as the world's fastest, most capable air superiority fighter jet. But did you know there is a jet fighter that can beat the F-22? Yes, there is a fighter jet named Northrop YF-23, and F-22 fighter jet pilots are terrified of this plane. Despite the powerful F-22 being chosen as the go-to fighter jet for the U.S. Army, the fighter plane YF-23 is still remembered throughout history. The jet fighter Y-22, now known as the F-22 Raptor, has many interesting features, but the YF-23 beats the F-22 when it comes to performance. The YF-23 is the pinnacle of contemporary engineering and has many advantages over the F-22. In this video, we'll find out the history of the unforgettable jet fighter YF-23 and why F-22 fighter jet pilots are terrified of this plane. Let's see which features of the YF-23A Black Widow fighter jet scare the F-22 fighter jet pilots. Shall we look back to the past to discover the origin of the YF-23? The United States believed that it might find itself in a horrific shooting battle against extremely heavily equipped Soviet units 40 years ago, when the possibility of nuclear war was quite real. The F-14 Tomcat and F-15 Eagle, two of the Air Force's operational jets at the time, were still in excellent operating condition, but newly developed Soviet fourth-generation fighters, such as the Sukhoi Su-27 and the Mikoyan MiG-29, were proving to be effective as direct rivals to American aircraft. The Advanced Tactical Fighter ATF competition was a defense contractor competition organized by the Air Force to discover a better solution. Two aircraft were selected as finalists after that competition: the YF-22, made by Lockheed, Boeing, and General Dynamics, and the YF-23, made by Northrop and McDonnell Douglas. Both of the aircraft were groundbreaking new creations that fulfilled all the American desires. Both aircraft had relatively similar capabilities. However, the YF-23 was quicker and proved to be harder to spot on radar, despite the YF-22 having greater maneuverability. The two planes' drastically different looks were, however, what distinguished them the most. The YF-23's exterior resembled other Lockheed designs. However, it had wings which had a diamond shape and thinner profile than the YF-22. An armament bay that could have stored 4 AIM-120 missiles and in-flight refueling capabilities were both included in each of the two YF-23 prototypes that were eventually constructed. The aircraft may have included a 20mm Vulcan cannon and an auxiliary armament bay for Sidewinder missiles if it had been put into production, but when forced to pick just one, the Air Force ultimately favored the YF-22, and that aircraft eventually evolved into the F-22 Raptor, which is still in use and regarded by some as the world's best fighter aircraft. But here comes the question: why F-23 is still known even after losing F-22? Do you think YF-23 was the one fighter jet that deserved to win the ATF competition? YF-23 lost the ATF battle, and there are many speculations that it was because of some political issues, because the YF-23 had more new HW technology than the YF-22, known as the F-22 Raptor. Are you at all curious to learn about the design of YF-23? Let's see why YF-23 is known as the fighter jet that could beat the F-22 Raptor. The fighter jet YF-23 was designed by McDonnell Douglas. The YF-23 is still considered to be the most technologically advanced aircraft than its competitor, the F-22. The YF-23 prototypes were 67 feet 5 inches in length and had a wingspan of 43 feet 7 inches, which is slightly bigger than the F-22. That gave the YF-23 a slight advantage in range and speed. The YF-23 had an unusual-looking diamond-shaped wings, a profile with significant area ruling to reduce aerodynamic drag at transonic and supersonic speeds, and an always-moving V-tail. The supersonic speed ranged from Mach 0.75 to Mach 1.2, which indicates that while being a fast overall jet, the aircraft performed well at low speeds. High-speed flight was also possible with trapezoid wing configuration. The YF-23s offered significantly reduced drag at supersonic speeds more than other designs, thanks to its compact size and heavy load. Additionally, the wing's tapered design minimized structural stresses, allowing the wind to be made thin, requiring less material during construction and lowering the aircraft's overall weight. Furthermore, the always-moving V-tail also offered many advantages to the YF-23. Do you think the wing design of YF-23 is better than that of YF-22? V-tail fins were slanted at an angle of 50 degrees. These V-tail fins were rotated in different directions to cause the front edges to move together or apart, which was how the pitch was primarily produced. The tail fin's rotation in the same direction was the main source of yaw. Paul Metz, a test pilot, claimed the YF-23 performed better than legacy aircraft at high angles of attack with trimmed AOA of up to 60 degrees. The cockpit. To provide the pilot with a good view, the cockpit was positioned high and close to the nose of the aircraft. A nose landing gear leg and two main landing gear legs were part of the aircraft's tricycle landing gear arrangement. Between the nose and the main landing gear on the underside of the fuselage was the armaments bay. This choice was made to retain the aircraft's stealth in all respects. It was decided to carry all of its weaponry internally rather than on the wing hardpoints. This is because weapons carried externally are the main cause of increased radar cross-section. A center stack and a side throttle are in the cockpit. The fighter jet YF-23 was propelled by two turbofan engines, each housed in its engine nacelle with S-ducts on either side of the aircraft's spine to conceal the axial compressors from radar signals. The frontal design of the inlets was trapezoidal, and they had specific porous panels there to take the turbulent boundary layer and vent it over the wings. The first YF-23 and the second PAV-2 were built. The first had Pratt & Whitney YF-119 engines, and the latter had General Electric YF-120 engines. Unlike the YF-22, which had thrust-vectoring engine nozzles, the aircraft had fixed-engine nozzles. As on the B-2, the YF-23's engine's exhaust was routed through troughs lined with heat-blasting tiles to dissipate the heat and protect the engines from infrared homing, missile detection from below. This enabled the ATF program to develop the first supersonic jet fighters in the history of the planet, conserving crucial fuel and extending the range of the aircraft. The ATF program placed a high priority on the intention of giving engines a ton of stable airflow and an airframe, which is difficult to detect on radar, and this problem is to do with the boundary layer air that forms around the fuselage of the aircraft as it flies. Compared to air that is offset from the aircraft's surface and readily absorbed by the aircraft's intakes, boundary layer air might propagate at a variable velocity and flow direction. Combining the two is not recommended since it can result in significant reductions in engine performance, thrust instability, or even worse. Boundary layer air can become extremely turbulent during certain flight regimes, greatly affecting or even choking the engine's performance. These problems are substantially worse at supersonic speeds. S-shaped air ducts serve to calm the air during supersonic flights so that the engine can suck it down without shock waves interfering with its functioning. They also serve to conceal highly reflective engine faces from radar waves, but the boundary layer problem remains unsolved. So, rather than building separate intake structures beneath the YF-23 with splitter gaps, Northrop built gauzing panels above and in front of where the fuselage meets the air intake's leading edge. These panels had numerous tiny holes punched into them, which allowed the boundary layer air that was sticking to the fuselage to be sucked up before it entered the air intake. On the upper side of the YF-23, a flush aperture and two small doors were used to exhaust this air. It functioned something like an invisible splitter plate, but it removed the air rather than splitting it. The boundary layer control system was the name of the automation system. YF-23 features are amazing, so why do you think it wasn't able to beat the YF-22? Despite political reasons, what could be the reason for YF-23's loss to YF-22? Some claim that the YF-23's lack of thrust-vectoring engine nozzle, in contrast to the YF-22, was a significant disadvantage for the ATF program and a decrease in overall mobility, which made the aircraft less agile at a low speed regime. However, the aircraft's designer said that they traded some agility for a little bit more survivability. In your opinion, which aircraft deserves more recognition? After 4 years of testing and evaluation, Lockheed's YF-22, which is now in service as the F-22 Raptor, was chosen as the winner over the YF-23. However, the designers of YF-23's two prototypes were confident that their aircraft was superior and technologically more advanced than the two. Nevertheless, political lobbying swayed the decision in favor of Lockheed's YF-22, which is currently in service as the F-22 Raptor. Do you believe YF-23 deserves to be somewhere other than a museum? Which fighter plane, YF-22 or YF-23, in your opinion, is deserving of the title of the best jet fighter? Now let's say farewell, but we'll catch up with a new video shortly. If you want to see more interesting videos like these, don't forget to like this video and subscribe to our channel. To receive updates, enable the notify button.